Right, good evening, boys and girls. It's Mr. Jongoni. We are meeting again today. Right, today we have got a different subject in terms of the topic. We are looking at solid geometry. Right, and in particular, we want to look at a situation whereby we have got combined solids. Right, this is an introductory part of our session. Tomorrow, when we meet for 2 hours, I'm going to look at a past exam paper looking at solid as well. So I want to touch the basics that you would require in terms of solid geometry, right? And we are going to look at the issues that we are going to focus on, mainly with regards to solid geometry. You'll be looking at copying the given views. And you'll find that there are a lot of marks that you'll be awarded for simply copying the views as required. Right, you may also be given, asked to draw a sectional top view or a sectional left view or even a sectional front view, depending on the position of the cutting plane, right? From there, you'll be required to define the true shape. I'm going to look at different methods that you can apply in terms of defining the true shape. Then the concept of hatching, labels, and all the hidden details that would be required in terms of the visibility of all the details if the object has been cut. So we are going to look at that today and focus on areas which most learners find difficult, and I'm going to explore and explain all that. Boys and girls, I don't want you to lose this statement. It's a very important statement, especially with regards to our subjects. I hear and I forget, I see and I remember, I do and I understand. Like always, I want you to make sure that you understand what you are doing so that you'll be able to apply these concepts on your own. So pay attention and listen very carefully. Thank you. Right, if you have got any queries, I want you to make sure that you write those questions down so that when we meet in our interactive session, you are able to pose those questions to me, and I'm sure I'll be able to respond accordingly. Thank you. Right, this is the scenario that we have today. This is our task. The task says, the given figure shows the front view and the auxiliary view of a combination of two right regular solids as well as a cutting plane, AA. The two solids form a single entity. Draw the following: the given front view, a sectional top view, all hidden detail must be shown. A sectional left view, all hidden detail must be shown. The true shape of the section on cutting plane AA, and all constructions must be shown. But I just want to explain one or two concepts before we get into the business of the day. All right, there is this word, all right, that has been mentioned, right? You talk about right, and we also talk about regular, okay? Right, this one, when you are looking at a right geometric solid, right, this is basically a solid whose apex in terms of position, right? If we draw a line, if we have got here, right, let's suppose this is a square pyramid or a square prism. If I were to drop down, right, this line from the apex point to the baseline like this, right? As long as the apex point is in line with the center of the base, right? We refer to this one as a right solid, okay? Right, you'll find that you may have situations, again, you may have a square base, but the apex is here, okay? Right, you have got your apex there, you have got your base there. So if we draw a line like that, okay, right, you'd find that this line coming to the center is not giving us an angle of 90 degrees. Hence, we refer to this one as an oblique, or it is inclined, okay? Right, so the concept of right, it means basically that the line in terms of the altitude line or line of symmetry is basically meeting the top or the bottom if it is a prism or a pyramid respectively at 90 degrees. So I want you to understand that concept so that we are able to apply it correctly. Then this one, if you are talking about a regular geometric solid, what it means is that all sides, right? All sides of the pyramid, okay, of the solid or solid are equal, okay? Right, so when we are talking about a regular geometric solid, if it is a pentagonal solid, all the sides of that pentagonal base are equal. If it is a hexagon, all sides of the hexagon are equal. The same applies, we talk about the square or any geometric solid for that matter. So regular, it means all sides are equal, okay? Now, there is also the issue that has been mentioned with regards to our task, a combination, okay? Right, so if we are looking at a combination of, right? We are looking at geometric solids that have been combined so that they would appear as one. That's why you find that the two solids form a single entity, but that would not make the two solids which have been combined lose entirely their identities, especially to do with sections. So I want you to understand that so that when we are looking at the sections, you will be able to appreciate that which we'll be doing. Right, okay. Now, the first thing, like we talked about with regards to our work, right, we said that the first part of our task is to copy the given views. So given two views like this, right, what is important is for you to understand. Now we are given the front view, right? And we are given an auxiliary view. So some learners would find it difficult to identify which one is the front view, which one is the auxiliary view. Now, an auxiliary view would show you the geometric shape of that particular solid, okay? Right, so in this case, if we look at that, we can basically say this is a square prism from here to there, and it is also a square pyramid, okay? Right? And the other thing that I just want to explain in brief, when we look at a prism, when we look at a pyramid, okay? Right, the prism, right, we say that a prism has a uniform cross section, okay? Right, it has a uniform cross section. What it means basically is that if we have got, right, this could be an elevation for a cylinder, right? So we do this, we draw a center line. Then when we look at the bottom, right, we bring this one, we draw that. Now, if we cut here, right, let's say this is cutting plane AA, like that, okay? The view that we will be able to see would describe a shape like this. So that is section AA, okay? Now, if we cut here again, right, with the cutting planes parallel to the baseline or the XY line, you can have your XY line like that. Then we label this one B and B, okay? Right, the resultant section that you will be able to see would still be this. So we can also say this is section BB, okay? Now, so what it means, the section is basically the same. So we say that a prism or a cylinder has got a uniform cross section, okay? No matter where you cut it, as long as the cutting plane is positioned the same, the resultant section that you are able to see is basically the same. That is the uniformity that we talk about. So that is a key characteristic of a prism, okay? But when we look at a pyramid, okay? Right, I'll take this one, right? And I'll say maybe it's a square, right? It's a square pyramid like this, right? So this has to be a square, okay? Now, you'll find that if I bring in a cutting plane AA like that, bring this one down, you'd find that I will be able to come up with a section like that. That is the part that would have been cut. Then if I cut here, all right, this is B, at the lower part, you'd find that the section that you'll be able to produce would be much bigger than that one for AA, okay? Now there is no uniformity in terms of the cross sections. So the key characteristic with regards to a pyramid is that it has a base and also has got a what? An apex like this. So I want you to take note. If you look at a cone, right, it is a special type of a pyramid, right? If you look at a cylinder, it is a special type of a prism. So those characteristics would come handy when we look at the different types of solids. Now, why are we looking at solids? Right, I want you to bring a picture, right? A picture of why it is important right now before our trial exams, or some of you might have started already. Right, look at this. Right, the 2020 National Revised ATP Annual Teaching Plan, Grade 12, Term 3, Subject EGD. Right, now let's look at this, the preparatory exams. Right, we looked so far at analytical, civil analytical, but look at question number 2. We need to know solid geometry, right, which we are going to look at today and tomorrow. We also need to look at interpenetration and development. Right, we'll need to look at interpenetration and development. Right, we also need to look at development of the transition piece. Right, I would explain all those concepts as we go, okay? But for now, our focus is on solid geometry, okay? Right, let us not waste time. Right, given a diagram like this, we are supposed to draw this front view and an auxiliary view. So the first thing that we need to do is to draw this. Then the next consideration that you need to make, we are supposed to draw a sectional top view. Remember, this is in first angle orthographic projection. So the top view would be at the bottom and a sectional left view. Right, the left view, if we are looking from this side, our left view would be on this side, okay? Relative to the position of the front view. Now, I'm going to do this. All right, I will come here. Right, what is the length? Is 80. So I'm going to draw a faint line at 60 degrees like this, okay? Right. From there, I'm going to define a line like that. Right. This line is, right, if we are looking at this, we have got this line generally, and we have got that line. If this is at 60 degrees, automatically this one is at 30 degrees, so that the two lines complement each other. Right. Now, because this is sitting at an angle, this is what you do. You take a 45 degree set square, right? I'm using the edge of the 30 degree set square as my t-square. Then draw a line faintly through the center like that. Once you have done that, you check the side. The side is 30 millimeters in terms of the side of the square base. Then you measure half of that, half of 30. You mark a point like this. This is 15 millimeters. Then you bring back your 45 degrees set square, supported by a T-square and a 30 degrees set square. Right, this is what you do. Then you draw a faint line like that. Right, if you measure the distance from here to there, automatically that would be 30 millimeters, okay? Here we go, that's 30 millimeters. You do the same, right, like that. And this, right, you slide it through to the other end, like that. Now, I have got my auxiliary view, okay? I've got my auxiliary view in place, but I can make this one slightly darker so that we are able to see. So from here to there, and also from here to there. Okay, then connect this one like that. Connect this one like that. Right, okay. Right, I may not need to make these ones very dark, right? These are the lines which are connected to the apex point. Like that, okay? Right, so now I have got my auxiliary view. I can label my auxiliary view A, B, C, D, okay, like that. I can label this one capital letter A to represent the apex point. The next thing that you would want to do after doing that, you need to create an auxiliary ground line. It's not given here, but it's between the auxiliary view and the front view. So about 10 millimeters or so, and making sure that you are able to cater for the points from here to there. So I'm going to draw a line like that, right? And label this one X1 and Y1 like that, okay? Right, from there, you create a base point, right? Anyway, just away from the front view. Then you measure the 84, which is given, which is required. Right, 84. Like this. Right. So from here, that's 1, 2, 3, 4. Okay. Right. This is the perpendicular height from the base, if you can check, from here to the apex point. Right, so once you have gotten that 84, then you project from the auxiliary view to the baseline, right, like this, right, and also like that. Remember, like I said, the first part of the problem is to make sure that you are able to copy the given view, okay? Right, then you measure 20, there's a millimeter, 20 from here to there, okay? That is for the prism. You mark like that. You bring this one in position, then like this, okay? Faintly, like that. Now, if you check, right, I would say from this point is point A, this one is point A. You can say A1, but for now, because I don't want to lose you in terms of this construction, right, you have got this one is B, and also this one is also B, right? It is also in line with point D as well as point D. This one is point C, and this one is point C, like that. All these points are connected to the apex point, which is capital letter A, like this. You do that. Right. So maybe just to make it easy, we can also say A1, B1, D1, so that we link like we did in descriptive geometry, D1, C1, and C1, okay? Right, and this one becomes capital letter A1. Right, from there, right, I can draw a line like this. all the way like that, right? And label this one X, Y. This is the normal ground line, right? I'm now in a position to outline all these in terms of the front view. I'll start with this one, from here to there, and then, yes, from here all the way like this. Project from here. Then you connect also from the base point to the apex. The base to the apex. Right. Now I have got the given views, right? And I also have got the ground line. I also have got the auxiliary ground line. The next thing that you need to do, right? You now need to use the principles of orthographic projection. We know that there is a relationship between the front view and the top view, right? But because we only have got a front view and an auxiliary view, so this is when the auxiliary view would come handy, okay? Because for us to be able to generate another view, we need at least 2 views. But if we have got the auxiliary view, we would take measurements from the auxiliary view. I would show you all that, okay? So what you need to do, from the front view, project lines from each and every point, like this, like this. But you do this faintly, like that. Right. So you drop down points from the front view. Maybe there's something that we miss, which we need to finalize. Right. If you check with regards to the diagram from here to there in terms of the cutting plane, right, we've got 9 millimeters. So we want to measure 9 millimeters from here to there. Like that. Then we have got a height from here to there of 58. Okay. So I'm going to measure this 58. Right, it is measured perpendicularly like that, okay? Then you draw a faint line, right? You connected this point to that point. That is your cutting plane. We shall use this later on. Right, faintly at first, then you darken this. Darken this like that. So we now have got our cutting plane in position. That's a mark as well, okay? Right, so if they say copy the given view, right, it should include the cutting plane as well, okay? So every line that would have drawn, including the cutting plane, that would be credited in terms of your work. All right. Now, the next thing that I would want you to do, first of all, establish the apex point, okay? Right? Establish the apex point, but this is what I want you to do so that you are fast, so that you are able to complete your work as quickly as possible. You create another ground line, like this, right? Just take view like that so that you'll be able to see. Right, I've got X and Y, I've got X1 and Y1. So I would say this is X2 and Y2. Once you have done that, you take your 45 degrees set square and you create a mitre line, right? At 45 degrees set square, you do this, okay? Right, such that the moment I establish a point here in terms of the top view, project it to the mitre line, then you take it to the left view. That way you are working with two views at once, so that you don't wait to complete the top view, then go on to the left view. So the moment you provide a detail on the top view, you transfer it via the mitre line to the left view. The first thing that we want to establish is the apex point. This is how you do it, okay? You stand on the ground line, locate that point or connect with a point which is on the auxiliary view. So from here to there, you take that distance. Take this distance, right, like this. Please make sure you are accurate. You take that distance. You go and stand on the apex point on another view like this. Then you mark. There you go. So we can actually say this is the apex point as seen in the top view. Just a moment. Writing this paper. Right. So that is the apex point. So I can say this is now A2. Okay. Now I have got this A2, which is in the top view. So you do this, take it to the mitre line and project like this. Not all the way, right? So here we have got, maybe you can do it all the way because it's in line with point D and point A. So you take this one up like that. Right, so I would say this is now A3. Now this is the apex, which is now in the left view side, okay? Remember, there are no marks for these labels, but as you would see, right, dealing with the section of a solid, these labels are critical, okay? Right, I now have got the apex point, I now have got the apex point. The next point that I want to get, if you check, this point A is in line with the point A for the base, A and C for that one. So where I have got point A, I can actually label this one. This is A2. Where is my other A? It's here, right? This is also A2, like that. Then I've got point C. I can also come here and say this is C2 and this is C2, like that. Right, remember the other part is for the prism, then the other part is for the base of the pyramid, okay? Right, the next distance that I want to take is distance to point B. Right, you do this from the ground line, which we refer to as the auxiliary ground line. So you open your canvas to there, or you can actually measure. You take this distance. Just a moment. You take this distance from here to there, like that. Then you go to point B. This is point B, then to the new ground line, which is the normal XY line, then you mark. Right. There is no other distance which is in line with that one for B, so this would project here. Where is the other B? It's here. So I project like this to the mitre line, then take this one up. Right. For A, remember A is in line with point, right? So this one now is my A3, right? Then you have got there, that's another A3, right? Which is in line with C. This is my C3, the other C is here, you project like that. This is also C3. I'm just using these labels so that you are able to appreciate what we are doing, okay? Right, here we have got B2, B2, like that, okay? Right, then if we go and we check for B, there is a B there, right? So this one is now B3, right? From here to there, this is B3. Forget about the cutting plane at this point. All what you are interested in is to define the frame of the geometric solid, okay? Right, so you've got B3 and B3. right? Later on, we'll connect these B's to the apex, with these A's to the apex, okay? Right, now I've got B and B in the top view as well as in the left view. Then the last point that I want to take is from here to there. Take that, right? You take this, go to point D, right, which is this one, the same A as or in line with point B, then describe a mark, right, like this, mark there, that's your point D, okay? Remember, if it is a prism, there are two D's, then you do this. So there is point D, and there is also point D2, D2, okay? Right, then you project this one up, like that. Right, we know that D is in line with point B, so there is D2, D3, sorry. Then the other one is here, which is D3, like that. Now, this point, if we are looking at this, you have got point A, which is this point A. We've got point B, which is this point B. Then we have got point C, which is this one. Then we have got point D. So you can connect these points, right? The first one is A to B, like that. Then B to point C, like that. Then C to point D, and D to point A, right? That is the first part, but there's also another point A, B, C, and D, right? You do the same, like that, to C, then D, back to point A. Now, you would see that this point A is connected to the apex point, which is our capital letter A. So I'm going to do that. So this one like that, and this one also like that. Right, point C is already connected, right? Point C is already connected, point A is already connected like that. So that is the framework in terms of our top view. Right, we are not going to outline this. You wait up until you consider the position of cutting. Right, I'm going to do the same. Right, if we are looking at this point, C, B, A, and so forth. So we'll start with this A, which is this one, A to B, B to point C, C to point D, okay? So I'm going to connect like this. Right, like that. Then you do the same, A, B, C. So we are going to show application of this using a past exam paper tomorrow, okay? Then this point is connected to the apex, point D should be connected to the apex. This one is connected to the apex point. So we are going to do that like that. Like this. Right. So now we have got the framework in terms of the geometric solid. If we were not doing this as a section, we were now going to look for the visibility in terms of the lines, okay? But for now, let's consider the cutting plane. Right, we have got this line, which is generator A to C. It's cut here. So if we project from here, it should also cut line C to A. Remember, we have got CA, and C2, A2, and so forth. But basically, the line is A to C, okay? So I'm going to project from here, from the position, then I get a point like that. That is my first point. Right, this one is going to cut A to B, A to D as well, okay? So I'm going to bring this one down like that. Right, D to A, which is this point, and B to A, which is this point. So now I've got this point, and that point. Last but not least, if you check, it's going to cut the base, which is A to B, as well as A to D, okay? Right, so I'm going to project from here, take this one down like that, okay? This is A to D as well as A to B. This is what you need to understand. As long as it is cutting the baseline, okay? Right, you need to just draw a straight line, or you look at this, project from this point of cutting and see which lines in terms of the baselines have been cut. If you project backwards, you can actually see, oh, it's line A to D as well as A to B. That is what you need to do if you want to check the visibility. Right. Once you have got this point, that point, and this one, and that one here, for A to B, which is this one, right? You connect these points. You connect this, right? Connect this as well as this one, like that. Then you also connect this one, right? This is already connected from here to there, right? This one, like I said, you connect and define it as a single line, then you outline this part. That is the shape which is formed by points of the cutting or the section of this. Forget about anything else, just outline that like that. Then this you connect as well. There you go. There is a particular shape that we have produced. Now you take your set square, right? You look for an appropriate set square. Here you can use either a 30-degree set square or a 60-degree set square. That would give you the appropriate hatching lines, right? I'm using 60 degrees, like that. This is part of the object that has been cut, right? But as you can see, right, from here, right, in terms of the part that has been cut, we did not go all the way. I only defined the part with regards to the pyramid, okay? So I'm going to hatch this part like that. Then I would also consider now, right, from here going downwards, which is A and so forth. So I'm going to proceed with this one like that. Make sure your hatching lines are equispaced. There you go. That is the part of the pyramid that has been cut. So if we bring this one down, but we did not complete. So you also need to factor in this part, okay? Right, as you can see, it cut A to D as well as A to B. It's also going to cut A to D as well as A to B. So I'm going to project this one down like this. Then it's also cutting here at this point and at that point. Right, remember it's from here to there, which is from here to this point and from here to that point. Let us also connect this as well. Like that. Right. Now, the definition of the part that has been cut from here to there will be this and that back to that. So I'm going to outline this. Yes. There you go. Okay. Right. Then the next thing that you would want to do, right, is to also hatch this one now in the opposite direction, right, because it should show that the components are different. Okay. Right. I'm going to do this. Right. Hatch this one like that, in such a way that you don't lose the identity of the signs. That is critical. There you go. Now, that is the part that we'll be able to see when the object has been cut. Right. Yes, you'd find that in certain literature, this could be assumed to be one entity, okay? But because we know that these are two geometric solids that have been combined, we want to differentiate in terms of the hatching. Just like we do when we are looking at isometry, or even mechanical hatching, where parts are adjacent, just to show that this is one part and that is another part. But of course, they've been cut by one knife, but they are still individual geometric solids, okay? When you have done this, then you consider now in terms of visibility, what else would you be able to see, right? When you are looking from the top, apart from the surface that has been cut, right? If you check at point A, when we remove this part, okay? Remember, for you to be able to see this surface that has been cut, you need to take off this part and you are left with this one. So the top part is removed, thrown away, okay? So you are still going to be able to see point A, which would take you to the point of cutting and point of cutting. So let us connect this. It's still visible, it's still there. So we are going to do this. And that, okay? Right. Then if you are looking again from the top, you will be able to see the remainder of C to A, this line here. So we are going to outline this from here to there, right, like that. You are also going to see the remainder of A to B, which is from here to there, which is from here to there, right? So as a rule, any lines which are on the outside and they are not cut, you outline those, okay? So we're going to outline this and also do the same this side. You outline that part, right? Now, the whole of A, small letter A, to big letter A, which is the apex point, that line has not been disturbed at all. So what are we going to do? We are going to draw this line as a hidden detail, simply because now it is coming across outlines. As long as a line is coming across a defined outline, that line has to be shown as a hidden detail, okay? And again, it is passing through the surface that has been cut, which means it's not visible. So I'm going to show this one as a hidden detail, right up to this point, okay? Though it can be extended, but I just want you to understand that from here to there, it's from here to there. But this line A has not been disturbed at all, so still it can also be shown as a hidden detail. That edge is still there, okay? Right. We have got this from here to there, but we also have got this one from here to B, from A to B. That line is still there. Right. So let's look for our B, which is here. Right. The remainder of that line, which is from here to there. So you are going to show hidden detail. This is the visibility that I talked about in my introduction. Right. Then there's also the remainder of A to D, okay, which would be stopped here. So you come there and show by way of dotted lines like that, or hidden detail. Right. I'm sure we have now covered everything that we want with regards to the top view. which is our sectional top view. Since this cutting plane has no specific direction, this is what you are going to do, right? At the bottom, you write nicely, right? You write nicely, sectional top view. A. Right, what it means is that this is a section, okay, right, or a view which contains a section that has been cut by cutting plane AA. Remember, a cutting plane is just an imaginary knife which is used in theoretical terms to represent the part and the position where an object would have been cut by that knife, okay? So instead of actually using a knife, because this is theoretical, we use a line like that. That line represented by a cutting plane, by a center line with thick ends like that, is what we refer to as a cutting plane, okay? I know you did this from grade 10 and up to now in grade 12, but because it's our revision exercise, I want to emphasize those key points so that you are prepared for the exam. All right, so here we are done with regards to this part. So the next thing that we want to do, we do the same thing again, but we have got this space A, B, C, and D, which is A, B, C, and D. Where is it cut? You project from here like this. So this is the point of cutting, this is the point of cutting, right? Which is like that. So I can even outline this like that. It's not going to change, right? Then you have got also A, B, C, and D. When you are looking from the left-hand side, what it means, again, the top part is removed in order to expose the surface that has been cut. So I'm going to project from the point of cutting like this, right, which is this point and that point, which will be connected like that. Now, this is the end part in terms of our section for the prism. So I can also define this one like this, like that, okay? Right, the next one that we want is generator A to B and A to D. Right, where is it cut? It's cut here, so I project like that, which is this point and that point. Last but not least is this one, which is A to C, which is that one. As you can see, again, AA has not been disturbed at all. So we have got, in terms of our section, we connect this point to that point, to this point, to that point, and that point, and this one today, and that one today. Let's do that. So I'm going to connect. But I'm going to connect here. Right, I do the same like that, then connect, like that. Right, if you are satisfied, you outline the shape that you have produced. Right, I'm going to outline this. Right, I'm also going to outline this. Connect this one. Then I'm also going to connect to this. From there, you can try your set squares. If a 45 degrees set square would do in terms of the position, you hedge like that. Hedging up to the common cutting position or the end of one geometrical solid. Remember, these hedging lines should be equally spaced. Then you change direction. Like that. But perhaps we could have used another angle in terms of our hatching. But I'm sure you are able to see, right? The auxiliary view at this point is of little importance. Right, okay. So once you have done this, the next thing now, you are looking from the left-hand side. What is the obvious line that you will be able to see, which would remain after the object has been cut? You'll still be able to see this line from here to there, okay? So I can outline this. Remember, you always start with the obvious, the known. Then you end up looking at the unknown, okay? Right, then you also have got this from here to there, which is B to A and D to A, right? Which is the remainder like this, right? When you are on the left, then you outline, and you also outline this like that, okay? Now, you are not able to see this point A, but it's there, it's not disturbed. So from here to the point of cutting, from here to the point of cutting, that detail has to be represented, right, like that, which you show by way of hidden detail, and also then hidden detail like that, right? Then A to A. This is another A. From A to A, there should be information. Again, you won't be able to see from that side. Then you represent this one by way of hidden detail. Then there's this part from here to the point of cutting, which is from here to the point of cutting, from here to the point of cutting. That detail again has to be represented by way of hidden detail like this. And you do the same this side. Right. This is the visibility that I'm talking about, or that I talked about earlier on. Then from here to there, right? From here to there, but there's already an outline. The outline will take precedence, okay? So you are simply going to define this part up to there. The rest you won't show, okay? Because there's already an outline. If you've done that, you now have got your sectional part, or the part that has been cut, as well as that part which has not been cut. Then you write neatly, either next or at the bottom, something like this. Right, you write section, sectional, left view, as a cutting plane AA, okay? Right, because the cutting plane has been shown, but it has no specific direction. Right, okay. Now, we now have got the sectional top view, so we can even go to our information paper. You tick, I did draw a given front view, right? I was able to draw a sectional top view. I was able to draw a sectional left view. Right, the next thing that we want to look at is the issue of the true shape. Now, what basically it means with regards to the true shape, for you to be able to see the true size of this surface from here to there, right? There's no way that you'll be able to see it when you are looking from the top. The distance from here to there will be shorter, thereby distorting the size, right? The other thing, if you are looking from the left-hand side, again, it will be shorter. You can only be able to see the true size of this part when you are standing perpendicular to the surface that has been cut. Right, okay? Now, you can either project it up like this, or you bring this one down, okay? I'm going to bring this one down, right? I'm going to align this one. Let me see. Align with my adjustable set square, so that we create an angle of 90 degrees. Like that. Right. Once we have done that, right, I'm going first of all to use the method which we refer to as auxiliary plane method. Remember, in descriptive geometry grade 10, we use auxiliary plane method as well as cone generator method, which can also be referred as rabattment, okay? So I'm going to project from here, right? Project lines. like this. Right, again from here, lines like that. Also, from each and every point that has been cut, you are going to do this like that. But you may also maybe need to extend these lines, right, like that. Then, once we have done that, you draw now a new ground line like this, okay? Right, you can label this ground line X3, Y, Y3 like this, okay? Now, this, if you are looking backwards, you'll be able to see the true size, okay? Right, in terms of the distance from here to there. Now, you now go back to the old ground line. Take the measurement from here, like that, to the point of cutting for this line C to A. Right, so you're looking at that, go to the ground line, you take this measurement like this, then you stand there and you mark, okay? So that is the measurement with regards to this point. So we can even say this is A4, right? Not necessarily A4 in terms of this point. Okay, so let me withdraw this part, which is A4, but it's the point of cutting, which is in line with the A to point C, okay? Right, the next thing that you want to do, you also take the distance from here to this one, right? Right, so you are coming from this point, or this one is for the top part, right? You are coming from this point, you relate it to the point of cutting, which is this one and that one, right? You take this one, right? Can you just correct something here? I think I missed this point, which was supposed to be here, okay? Right, which is here. It happens in an examination, you are under pressure, right, but, right, okay. So I take my 60-degree set square again, extended this, and extended that. So the point that we want is from this point to there, which is also from here to there, okay? Right, so this line, boys and girls, it is not supposed to be there, right? So it's here and there, okay? So you take this distance, remember from the point of cutting to this point like here, you take that distance, you go to the point of cutting, you stand on the new ground line, which is your X3, Y3, you mark something like that. You do the same, standing on the same ground, because that is for also in line with the other point on the extreme, right? You take that, you take this distance, you go to the point, stand on the new ground line, and you mark like that, right? Then, last but not least, you have got this point, which is for that one. You stand here, right? You take that distance, right? You go to the point, you bring it here, then you mark, okay? You do the same on the other side, right? You stand here, open it to this end, which is this end, okay? Right, then you stand there, and you also mark. Right, as you can see, we are slowly establishing our shape. So we are going to connect this point to there, like this. And we are also going to connect this one to there, like that. Then this should be connected here and also there. Right? The true size, which we refer to as the true shape of this part from here to there, there, and there, is now taking shape. Right, but we also need this one and that one. We do the same thing. Right? This is the point. You stand there, take the distance, This is the distance. Go back to the point of cutting, but you stand there, then you mark. Okay, but you do the same. It's in line with that. You come here, you take this distance, right, which is this distance, but from the ground line, go to the point, to the new ground line, and you mark like that. Right. You connect this point to that point, like this. You also connect this one to there, like that. Now you can outline this, you can outline like that. You can also do the same thing, right? Remember, there are two solids. You can also define here and outline here. Do the outline, right? Do the outline. Right. There you go. You now have got the true size. This part is basically able to cover the distance from here to there. So we refer to that one as the true size. Now you check again with the set squares, which one would ideally be able to hedge that. Maybe let me change. Let me look for 60 degrees, but this one will do. But I'm going to hedge like this. Like that, okay? But that is the first part. The other part, I can actually out a hedge using a T-square, like that. But in the opposite direction, like this. There you go, okay? Right. This is what we refer to as the true shape, and the method that we have used is the auxiliary plane method. So I can write here that this is true shape. Section AA, right? Right, that is the true shape using the auxiliary plane method. Right, so now we have got the true shape, we have got the sectional top view, we have got the sectional left view. Now I want us to be able to apply another method, which is not this one. Remember, there are so many methods. We will look at these ones maybe some tomorrow. But I want to apply another method that we can use, okay? But what you need to do, right, at this point, right, at this point, just raise a line like that, faintly, right? This point is this one from here to there, right? Then the next one that you need to stand here and open like this, open to that. You see this? Right, you describe an arc to the vertical line, you do the same, open to the next point of cutting, you describe like that, open to the next point of cutting, you describe like that, okay? Right. Once you have done that, you now transfer these heights like this, like this. There you go, okay? We know the distance for this part is from here to there. Then I want this one. This is what you do. You project this one up, right, to that point and to that point. The next one, is this one to this line and that line like that. This is very fast. Then this other one is basically you extend this one. There you go. If you connect this like that, connect it to this one like that, connect it to this one like that, and ultimately touching the original, which is this one and that one, and this also is connected there. There you go. You'd find that this is equal to that. Right, I'm going to outline so that we are able to see. There we go. Right, and you can break so that you catch them separately. Like this. Right. Once you have done this, you now take your set square. Let's try if the 45 would work, maybe. Hatch nicely. Remember, hatching lines should be equispaced and they should be lighter than the outline, but they should not compete with the outline. Nicely. Then I can hatch this the opposite direction or in another direction. Remember, speed is critical. You may know everything, but if you don't finish, you are not going to get the marks. So speed, neatness, and accuracy. As you can see, my drawings, I use a pen, right, which means I am making sure that I minimize mistakes as much as possible, okay? Right. Then you can also label here, that's true shape. True shape, section AA. Right, so this method is by what we refer to as the cone generator method, okay? Or the rabatting, right? You are standing somewhere, you create some kind of a cone, okay? Right, so you have got rabattment and the auxiliary plane method. Boys and girls, this is basically the basics in terms of solid geometry. So when we meet each other tomorrow, we want now to look at the past exam paper, maybe 2018, maybe 2019, the ones which are recent, so that we link with the latest trends in terms of examinations. I hope you enjoyed the lesson and I wish to see you again tomorrow. Good night.